Hey everyone, welcome back to the channel. In today's video, we're going to dive into BJT transistors and explore how they work. For NPN transistors in linear mode, the base emitter voltage, VBE, is greater than about 0.7 volts, and the collector emitter voltage, VCE, is greater than around 0.2 volts. The current gain beta relates the collector current, IC, to the base current, IB, like this. IC equals beta times IB. In saturation mode, VBE is still around 0.7 volts, and VCE drops to about 0.2 volts. Here, the current is less than beta times IB, and the emitter current, IE, is the sum of IB and IC. For PNP transistors, it's pretty much the same but reversed. The base emitter voltage, VEB, needs to be above 0.7 volts in linear mode, and the collector emitter voltage, VEC, stays above 0.2 volts. In saturation mode, VEB stays at 0.7 volts, and VEC drops to around 0.2 volts, with the same IC equals beta times IB relationship. Here we have a basic NPN transistor circuit. The base of the transistor is connected to a potentiometer, which allows us to adjust the base voltage VBE. The emitter is connected to ground, while the collector is linked to a 10 kilo-ohm resistor, which then goes to an LED. The LED is connected to VDD, the positive supply voltage. This circuit is great for simulating and analyzing the transistor's behavior in different operation regions by adjusting the values of VBE and VCE. Now let's adjust the potentiometer to 0% of its length, meaning the base of the transistor is effectively connected to ground. Now let's check the currents and voltages on the transistor. As expected, it's in cutoff mode, VBE is less than 0.7 volts, and no current is flowing through the transistor. Next, let's adjust the potentiometer to 100% of its length, which means the base is now connected to VDD, allowing a small base current to flow. As we can see, VB is 5 volts, which is greater than 0.7 volts, and VCE is less than 0.2 volts, putting the transistor in saturation mode. Also, notice that IC isn't equal to IB times beta, where beta is fixed at 100 for this transistor. Now, I've adjusted the potentiometer from 100% to 15% of its length, which decreases the base voltage from 5 volts. Now, with VB greater than 0.7 volts and VCE greater than 0.2 volts and IC equal to beta times IB, we're in linear mode. This is the active region where the transistor amplifies current, making it essential for applications like signal amplification in circuits. Now, let's implement this circuit in Arduino. Thank you for watching. Don't forget to like and subscribe. If you have any questions, feel free to leave them in the comments. I'll be happy to help. See you in the next video.